Hi, Sally Walker here, your hormone and slow age expert. So what kind of jobs do the mitochondria have? We know very well that they produce this energy currency called ATP, which is major important. But do they do other things as well? Well, the answer is absolutely yes. They do a lot of other jobs at the end of the day. So they're very much involved with something called apoptosis, which is programmed self-death. So the mitochondria actually instigate this when they can see that there are parts in the cell which are not functioning properly, etc. So they actually program or initiate apoptosis. So during energy production, they will be producing heat, so your temperature. So if you think about this, if you measured your temperature after you'd eaten a big meal, I mean, even if you don't really need to measure it, do you? You often feel very warm after eating a big meal, don't you? And tired, because all the energy has gone to your gut, obviously, for digestion, but it's also gone to the mitochondria to get rid of this food, to oxidize it to make energy, and that gives you a little bit of an increase in temperature as well, because there is heat when we produce ATP. So the mitochondria will also produce CO2, so carbon dioxide, and water as waste products from the ATP production. And they also are the major production site for free radicals, or what we call reactive oxygen species. Now, this is not all bad. So free radicals, reactive oxidative species are very important because they're signaling molecules, and they are a very important part of our immune defense. So we need some, so that's why we make it. So I think it's about 2 to 5% of every oxygen you breathe in will become a free radical. So, but we don't want too many of them. And if we do get too many of them, and we don't have the antioxidants, which are necessary to neutralize the free radicals, we will then create something called oxidative stress. And basically oxidative stress is probably what's killing us. And it will definitely be messing up your mitochondria. So, but it is important that we have some. We can't live without free radicals, because then our immune system wouldn't work properly. And then we'd be setting ourselves up for all kinds of infections. So we do need them. So what else it does? It produces steroid hormones. Oh, that's interesting, Sally. So do you mean that the mitochondria are producing estrogen? Oh, yes, I do. So it's amazing. So it all starts with the mitochondria receiving some cholesterol. So you've got to get cholesterol into the mitochondria, get it through those membranes into the mitochondria. And there it will be changed to pregnenolone. And then pregnenolone will transfer out into something called the endoplasmic reticulum, where there's loads of enzymes, and there pregnenolone can be converted to progesterone, to testosterone, to estrogens. But it can also come back into the mitochondria again, and in the mitochondria, pregnenolone will be converted to cortisol. So yay, we produce all of these steroid hormones. So the steroid hormones means they're made from cholesterol. That's why cholesterol is coming into the mitochondria. So isn't that exciting? So you're thinking, yeah, but Sally, I thought it was in the adrenal glands, or I thought it was in the testicles, or I thought it was in the ovaries. It is, but it's in the mitochondria of these particular tissues. It could be in the brain, in the adrenals, in the testicles, in the ovaries, everywhere where we will produce estrogens, cortisols, etc. It will be in the mitochondria of that particular tissue, in those cells. So busy bees, these little mitochondria. So just think about this. If cortisol is being produced in the mitochondria, and your mitochondria are not working properly, they're a bit tired for some reason or other, they have dysfunction, then that might be the reason why you're not producing enough cortisol. Interesting, hey? Very, very interesting indeed. We need to understand how fundamentally important these mitochondria are, actually. Absolutely. Oh, and there's lots of studies out there now looking at this, and also ladies, estrogen. We know we lose a lot of our estrogen around menopausal times when the ovaries retire. Yes. Well, this is a major problem because the because estrogen, one is produced by the mitochondria. It's not produced in the mitochondria. It's produced in the endoplasmic reticulum, but it's instigated by the mitochondria, okay? But the other thing is, we know that estrogen actually works on the mitochondria, so it helps them work properly. Something to do also with that. They work together with these sirtuin proteins. So have a little look at those. There's an article about this in the blog as well. So estrogen, major important hormone for the function of mitochondria. So think about that. Might be one of the reasons, the main reasons why the brain doesn't work properly or as well as it did before menopause, or bone health or heart health and cardiovascular health. All these kind of things might be fundamentally because there's not enough estrogen in the cells to make the mitochondria work properly. Ooh, we need lots more studies here, don't we? So these are one of these things about aging that we need to understand more and more about, and it definitely makes the estrogen replacement therapy, it makes it more and more important every single day that we are replacing estrogen. And don't wait, ladies, don't wait until your ovaries stop working. I think that we will find, the studies will demonstrate quite clearly at one point that we need to already start supporting it around the age of 40, where estrogen is beginning its gradual decline. Anyway, time will tell. I'm not going to be hanging around. I'm definitely using as much estrogen as I think I should be. I noticed a difference with my energy levels when I started using it, because I did have a little bit of a break from it at one point. But anyway, that's my story. Mitochondrial health, we got to look after it so it can do all its jobs. Happy hormones, happy health.